Hi, I'm Sandy Chaika from Riverside Brookfield High School, just outside Chicago, Illinois, and I'm here for the AP Daily Practice Session for APCS Principles. Before we get started, remember you can click on the link in the video or in the video description to access the PDF that will have all the items we're going over today. So let's go ahead and get started. We're going to look at Big Idea 1, Creative Development, as well as Big Idea 3, Algorithms and Programming. Let's start it up. Which of the following is a true statement about program documentation? A, program documentation should not be changed after it is first written. B, program documentation is only needed for programs in development. It is not needed after a program is completed. C, program documentation is useful when programmers collaborate, but not when a programmer works individually on a project. And D, program documentation is useful during initial program development and also when modifications are made to existing programs. So documentation, you might have also in your classes heard of this as comments. So these are things we might put in our program that the computer does not execute. It is meant to be either for the users or for the programmers themselves. So A, should it not be changed after it is written? Well, no. Actually, you might need to update it because you've made changes in it or even tell what the new version is. Is documentation only needed for programs in development and not needed after the program is complete? Absolutely not. In fact, sometimes programmers are going to make updates and it's really useful if they already have documentation in there so they know what they can update more quickly. Program documentation is useful when programmers collaborate, but not when they work individually. Now, I can tell you, I use documentation to help me keep track of what's going on in my own programs. And also, you don't know when you might need to use that program, maybe 1 or 2 years down the road. So the documentation is useful. The documentation is useful during initial program development and also when modifications are made. That is true. So that is our true statement, letter D. If you want to look at more information about documentation, we have 1.3 Daily Video 3. In question 2, the procedure below is intended to display the index in a list of unique names called namelist, where a particular name target name is found. If target name is not found in namelist, the code should display 0. So we can see our code here, procedure find name with the 2 parameters, namelist and target name. Index starts at 0. And we're going to go through a loop for each name in the list, update index by 1. And if the name is equal to target name, found index becomes index, otherwise found index becomes 0. After the loop is over, we'll display found index. Which of the following procedures calls can be used to demonstrate that procedure does not work as intended? So again, we want to look at procedure calls. So find name, Andrea, Ben is the list with Ben as the target. If with the same list, Andrea, Ben, find name, looking for Diane, find name, Andrea, Ben, Chris, looking for Ben, find name, Andrea, Diane, Chris, looking for Ben. We're displaying the index in a list if we find the name. Otherwise, if it's not found, we should display 0. So let's take a peek at this. We're looking at the procedure calls. If I do find name, Andrea, Ben, now I'm looking for the one that shows that it does not work. If I'm looking for Ben, index becomes 1. Ben does not equal Andrea, the first name, so found index will be 0. The next name is Ben. Ben does equal Ben. Index had already been updated to 2, so found index will be 2. The loop is over and it'll display. So this works, so it's not showing there's a problem. If I have the list Andrea, Ben again, and I'm looking for Diane, well, everything will update appropriately. Found index will always be 0 because Diane is not equal to either one. And that is fine. That's what we want. If I have Andrea, Ben, and Chris, well, when we have Andrea, index is 1. Andrea does not equal Ben, so found index is 0. Then we get Ben. At Ben, index is 2. Ben does equal what we're looking for, so found index will become 2. This is looking good until I realize I'm going to have to also look at Chris. Chris is at index 3. Chris does not equal Ben, so found index gets reset to 0. So it will display 0 even though Ben was at 2. That's a problem. If I look at D, just to make sure, Andrea, Diane, and Chris, notice none of those are what we're looking for, which is Ben. As a result, found index will always be 0 through every check of the list. And so that one does work as anticipated. So C is the only one that demonstrates the procedure does not work as intended. All right, we have a programmer wrote the program using a list of numbers called numList. The program is intended to display the sum of the numbers in the list. In order to test the program, they initialize numList to 0, 1, 4, 5. The program displays 10, and the programmer says that's good and concludes the program works as intended. Which of the following is true? Okay, the sum of the numbers in the list is what we're trying to do here. Notice we start the sum at the first number in the list. So is this conclusion correct? The program works as intended. Well, right now it looks like it because sum starts at 0, then we add 0, which doesn't change it, and then 1, 4, and 5, we get 10. But let's look at the others. The conclusion is incorrect. The program does not display the correct value for the test case. The conclusion is incorrect. Using this test case 0, 1, 4, 5 is not sufficient to conclude the program is correct. The conclusion is incorrect. Using the test case 0, 1, 4, 5 only confirms that the program works for lists in increasing order. All right, well, A is going to be a problem because we've only tested one thing. We should never conclude something works with just one test. Okay. B is not correct because it does actually give us a correct result for that list. We said we need to do more. So let's look at D. Does this confirm it works for lists in increasing order? Well, let's say that my first number was -1. Well, then sum would start at -1. Then I would add -1 again, which would give me -2. -2 and 1 is 1, plus 4 is 5, plus 5 is 10. But if -1 was here, that sum should have been 9. So C is our correct answer because it actually it doesn't work for even if it's in increasing order. The only time this one will work is if the first number is 0. All right, in a certain district, 20% of the voters are expected to vote for candidate A in an election. The computer program below is intended to simulate the result of the election with voters and display the number of votes received by candidate A. So sum is 0. We're going to repeat this n times. We have a missing condition here in our if statement. Every time that if is true, we're going to add 1 to sum and display the sum. We want to know what can be used to replace missing conditions so the program works as intended. Select 2 answers. So we're going to need some randoms. Random 1, 5 equals 1. Random 1, 5 is less than or equal to 2. Random 1, 10 equals 2. Random 1, 10 is less than or equal to 2. Now remember, we want to simulate 20%. So which of these will simulate 20%? Well, if I say 1, random 1, 5 will give me 1, 2, 3, 4, or 5. One of those would be correct. So 1 out of 5 is 20%. So A looks good right now. B, if I said it's less than or equal to 2, that could be 1 or 2. So that's 2 out of the 5, which is 40%. So that's not going to work for 20%. 1 and 10, if I say it's equal to 2, there's only one option 2 out of 10 choices. So 1 out of 10 is only 10%. That does not work. But if I do random 10, so I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I say less than or equal to 2, that's 2 choices, 1 or 2. So 2 out of 10 is 20. So A and D are both correct answers. To review random, in section 315, go to daily video 2. All right, a new bank wants to make some changes to customers to make a priority by minimizing the amount of time a customer waits in line. The bank is considering 2 options: a single line, where the customer at the front waits for the next available teller, or separate lines for each teller. The bank decides to use a computer simulation to simulate these 2 options to determine the average wait time for customers. Which of the following is not true about the bank's plan? The bank can incorporate other factors, such as the number of tellers in the simulation. The bank can use the simulation to investigate these 2 options without causing inconvenience for customers. The bank may consider a new alternative based on the simulation results. The simulation will not produce usable results because actual customer data are not available. So when I go to do this, remember, we're looking at 2 options. And we were looking at the single line or separate lines. So can the bank incorporate other factors? Of course they can. The number of tellers might actually change how the simulation works. So that is something they can do. Can they use the simulation to investigate these two options without causing inconvenience? That's the whole idea of doing a simulation, is not putting the customers through the pain of figuring out which one is better. So they're actually doing it in a simulation, so they do not inconvenience. So this is true, actually. The bank may consider new alternatives based on the simulation results. Well, hopefully that's the whole purpose of doing the simulation. So that's true. The simulation will not produce usable results because actual customer data are not available. Well, that's false. That's one of the things they are using in their simulation is the customer data. So the one that is not true is D. If you want to look at real world phenomenon, 316, daily video 1. And if you want to look at comparing simulations to real world phenomena, consider 316 daily video 2. All right, we have another code segment here. We want to look at displaying the average of all elements in a list called numbers. There's always at least one number in the list. Count starts at 0, sum starts at 0. We're going to go through each value in the list, add 1 to count, add the value that we got from the list into sum to accumulate it. And each time we're going to divide the sum by the count. When the loop is over, we'll display the average. The programmer wants to reduce the number of operations that are performed when the program is run, which change will result in a correct program with a reduced number of operations performed. We're looking at interchanging lines 1 and 2, changing lines 5 and 6, 6 and 7, or 7 and 8. Remember, there's always at least one number in the list. Well, if I change lines 1 or 2, that is not going to change the number of operations performed. It's just which order we set the variables. So A is not the answer. If I interchange 5 and 6, both calculations are being done. They're just being done in opposite order. So again, no reduction in number of operations performed. If I change lines 6 and 7, well, I'm still doing both operations. And quite frankly, I'm also getting an incorrect average. So that's not going to help. But if I change 7 and 8, what that will do, it'll move the average equals sum divided by count outside the loop. That way I'm only doing the division once after the sum and count are calculated. So this division and assignment will only occur one time rather than occurring for every single number in the list. D is our answer. Number 7, which of the following statements is true? Every problem can be solved with an algorithm for all possible inputs and a reasonable amount of time using a modern computer. Every problem can be solved with an algorithm for all possible inputs, but some will take more than 100 years, even with the fastest possible computer. Every problem can be solved with an algorithm for all possible inputs, but some of the algorithms have not been discovered yet. And there exist problems that no algorithm will ever be able to solve for all possible inputs. So let's take a look at this. Can we solve every problem with an algorithm? No. Why? Because there are undecidable problems. Every problem can be solved? Well, again, we have undecidable problems. That takes out B as well. Every problem can be solved with an algorithm. No, because we have undecidable problems. So D is actually our answer. We want to talk about undecidable problems. And if you're not familiar or forgot about that, you want to look at daily video 1 in section 318. All right. A certain computer game is played between a human player and a computer-controlled player. Every time the computer-controlled player has a turn, the game runs slowly because the computer evaluates all potential moves and selects the best one. Which of the following best describes the possibility of improving the running speed of the game? The game's running speed can only be improved if the game is played between 2 human players instead of with the computer-controlled player. It can only be improved by using a process that finds approximate solutions every time the computer-controlled player has a turn. The game's running speed cannot be improved because computers can only be programmed to find the best possible solution. And the game's running speed cannot be improved because the game is an example of an algorithm that does not run in a reasonable amount of time. So when I look at A, well, it's not going to help if it's only between 2 human players because the reality is I'm still going to have the issue of every turn. For B, can it be improved by using a process that finds approximate solutions? Some of you might have remembered that something called heuristic solutions. That is something we could do with the computer, so that looks kind of good. The game's running speed cannot be improved because computers can only be programmed to find the best possible. No, we can use heuristic algorithms. And it cannot be improved because the game is an example of an algorithm that does not run in a reasonable amount of time. We can make it reasonable if we use heuristic, which would make approximate solutions. So our answer is B. You might want to review efficiency in 317 daily video 1, as well as heuristic solutions in 317 daily video 2. Thank you very much for coming, and I hope you'll look at some of our other videos. Good luck on your exam.